Okay, first for problem 1, we're going to find the domain for each of these functions. So starting with a, let's go ahead and factor the denominator of h of x. So h of x equals x plus 2 over, that should be x minus 5, x plus 2. Okay, and then we notice that we have a common factor on the top and the bottom, so that's where a hole would be in our graph, but I don't think we're too concerned about that. So we just want to look at our restrictions. We know certainly x cannot equal negative 2 and it cannot equal 5. Why? Because that's going to make my denominator go to 0 or make my function undefined. Everywhere else, my function should be all right. So if we write that in interval notation, we should be going from negative infinity. We make our first stop at negative 2. And then we have a union, negative 2 to 5. Any values in between negative 2 and 5 are acceptable. And then anything greater than 5. Okay, great. Next, let's look at b. And for g of x, we have a square root in our denominator. So I want to look at where we definitely know our denominator cannot be equal to 0. But I also know that square roots can't have negatives underneath them, otherwise we'll have imaginary numbers, and that's not going to be included in my domain of real numbers. So I want to look at where this 1 minus x portion, I want to see where this is strictly greater than 0. If it's equal to 0, then that means my denominator is 0, and that's not the case. So I want to see where 1 minus x is greater than 0, or where it's positive. And not equal to 0. So we can go ahead and solve this inequality, and I'll get negative x is greater than negative 1. So x is less than 1. Remember, when we divide by a negative, we need to flip that inequality sign. So if x is strictly less than 1, then our domain would just, if I were to draw a little number line, I have 1 right here, and x is going to be less than 1. So anything less than 1 I can plug in. So my domain is going to be from negative infinity all the way up to 1 with a parentheses, because that one is not included. Okay, next let's take a look at part C, and we're going to look at k of x. And so we have a square root and we have some stuff in the denominator. So I'm going to go ahead and factor out that denominator a little bit, because we can write that as 2 times x minus 1. And then immediately from the get-go, we know that x cannot be equal to 1. Otherwise, it would make our denominator equal to 0 and our function undefined. Okay, so then what else do we need to occur? Well, we also need this x plus 1. We need this to be greater than or equal to 0. Here it can be equal to 0 because it's in the numerator. The last problem that we had to make sure that our 1 minus x was strictly greater than 0 because it was in the denominator, but this one can be greater than or equal to. So we'll look at where x plus 1 is greater than or equal to 0. And we'll see where that's true. So x needs to be greater than or equal to negative 1, and x cannot be x cannot be positive 1. So let's draw a little number line. I'm going to draw a filled-in circle for negative 1, and then an open circle for 1, since it's not included. And then x needs to be less than negative 1, greater than or equal to negative 1, but it cannot be 1. So our domain should be from negative 1 to 1, parentheses, union, this 1 to infinity. Great. Okay, last but not least, we have h of x again, d, and we have square root of x minus b over the square root of x minus a, so we don't have actual numbers to think about this time, but we know that 0 is less than a is less than b, so that'll be important later. So for our h of x function, what needs to be true? Well, I know that my x can certainly not be equal to a, otherwise my denominator will be equal to 0. And similarly to the last problem, I still want what's under my square root to be greater than or equal to 0. It can be equal to since it's in that numerator. So we'll see where that's true, and that just tells us that x needs to be strictly greater than b. So let's go ahead and draw our number line. And we know a is less than b, so I can draw, and we know that they're both greater than 0. So I can go ahead and write 0, I'm going to draw an open circle for a, and maybe a closed circle for b. So we know that x cannot be equal to a, and x is greater than or equal to b. So I think our domain here should just be from b to positive infinity. Okay. Next for problem 2, We are given a function and we need to find each of the following. So we'll start with a, we need to find f of -2. So we'll go ahead and plug in a -2 wherever we see an x into our function. So f of -2 equals 3 times -2 minus 1 squared. So this will be 3 times a -3 squared, or 3 times 9, which is 27. Okay, great. Okay, next we need to find the average rate of change over the interval from -2 to -1. So we'll go ahead and use the formula. Our average rate of change over that interval should be given by f of -1 minus f of -2 over -1 minus a -2. Okay, so this is our average rate of change. And so we've already computed f of -2, but first we need to calculate f of -1. So let's go ahead and do that. F of -1 is going to be 3 times -1 minus 1 squared, which is the same as 3 times -2 squared, which is the same as 3 times 4, which is 12. Okay, great. So now we're ready to plug all of our information into our formula. So our average rate of change should be f of -1 was 12, and then we'll do minus 27 all over a -1 minus a -2. So that's really plus 2. Okay, great. And then that will give me, I will have a -15 up top, and then -1 plus 2 is just going to be 1. So my average rate of change should be 15, -15. Next, we're going to go ahead and compute f of -2 plus h. So f of -2 plus h, we're just going to plug in -2 plus h wherever we see an x. So this will be 3 times -2 plus h minus 1 squared. Okay, so then I have, this is going to be equal to 3 times -3 plus h squared. And so then we can go ahead and FOIL that out. We should get equals 3 times 9 minus 6h plus h squared. Okay, great. So then we should get 27 minus 18h plus 3h squared for f of -2 plus h. Okay. Okay, last but not least, we're going to find the difference quotient. So we've already computed f of -2 plus h and f of -2, so we just need to subtract these two. So I'll do 27 minus 18h plus 3h squared minus our f of -2, which was 27, all over h. And so we just need to simplify this, and h cannot be 0 since it's in the denominator. Okay. Our 27 minus 27 is 0, so I just have -18h plus 3h squared over h. And I can divide each term by h since everything has an h. So once I divide this out, this will be -18 plus 3h, where h cannot be equal to 0. Perfect.
Okay, for this problem, we're given the graph of a function g with domain -infinity to 12 and inflection point 6.5, 5.25. And then we're asked to find each of the following. So first we're finding where the function's increasing. So as we look all the way at the left, we have -infinity all the way up until we get to this peak here at x equals 4. So that's where we're first increasing. So from -infinity to 4. And then we need a union if we're going to have any other intervals. And then looking at 9 all the way up until 12. We notice we're increasing. So we would union that with the previous one. And then we're not increasing anywhere else. So that's all for increasing. And then for decreasing, we have the opposite. So from 4 until we get to 9, we are decreasing. And then that's it actually. So just from 4 to 9, we notice that we're decreasing. And we don't include either of those points because those are the peaks or the valleys, and at those points we aren't decreasing or increasing. So the local maximum and local minimum are just the tops of hills or bottoms of valleys. So our local maximum would be right here at x equals 4, y equals 36.5. So the value of our maximum would be 36.5, and it occurs at x equals 4. And then for our minimum, it's just the bottom of a valley. So right here at x equals 9, y equals negative 26. So that means we have a minimum of negative 26 that occurs at x equals 9. So for our absolute maxima and minima, we're looking for the highest and lowest values on the function from this whole interval. So we're looking between negative infinity and 12 to see what the lowest value and what the highest value is. So the highest value we can see is right here, where we have a y value of 68.5. So that means that's our absolute maxima. But for our absolute minima, we can notice that this function is going to keep on going down forever, so it's never going to reach any sort of absolute minimum value. So for this one, we would say NA. So for looking where it's concave up and concave down, we know that concave up is like a smiley face, concave down is like a frowny face. So where do we see any sort of happy face? I would say that would be from here to here. So from 6.5 to 12, we're concave up because we're like a smiley face, I guess. So we would say we're concave up from 6.5 to 12, and neither of those points are going to be included. And then for concave down, we're looking for the frowny face. So that would be from here to here, or from negative infinity to 6.5. That's where we're concave down. And it makes sense that for our concave up and concave down, one starts at 6.5, the other ends at 6.5, because we have an inflection point at 6.5. And the last part of this problem asks us to find if the rate of change is positive, negative, or 0 at each of the following x values. So first we're looking at x equals 3. So if we go to 3, that's like right here. And the rate of change would be the tangent line at that value, or at that x value. So at x equals 3, we have a positive slope here. So that means our rate of change would be positive. So for x equals 4, well, that looks to be the top of a hill. So that would be a horizontal tangent line or a 0 slope. So we would say it has 0 rate of change. And then at x equals 5, that would be right here. So at this point on the graph, we would have a tangent line like this, which has a negative slope. So that means our rate of change would be negative. So for problem 4, we're finding the limit as x goes to infinity for each of the following. So looking at A, we notice that we have an x in our denominator, but in our numerator, all we have is a number. And since x is going to get bigger and bigger as x goes to infinity, that means we're going to be dividing by a bigger and bigger number. And so if we divide everything by a really big number, then we're just going to go to 0. So y goes to 0 as x goes to infinity. So for part B, we have some similar things happening. So we have 5 minus 1 over x. So for 1 over x, x is going to get bigger and bigger and bigger, while 1 stays constant, so that term's going to 0. Same with 2 over x squared. So those both are going to 0. So all we're left with is 5 over 3. And so our limit goes to 5 over 3. For part C, we have x minus 4 over 3x squared plus 1. So if we were to try and make this simpler, we could multiply the numerator and the denominator by 1 over our highest power of x, which is x squared in this case. So essentially we're dividing the numerator and denominator by an x squared. So that would give us x minus 4 over x squared over 3x squared plus 1 over x squared. And then x over x squared would just give us 1 over x. 4 over x squared would give us 4 over x squared. 3x squared over x squared is just 3. And then 1 over x squared is just 1 over x squared. And then out of these terms, we notice that 1 over x would go to 0. 4 over x squared would go to 0. And 1 over x squared would go to 0. And so this would be 0 over 3, which is just 0. And then lastly, for part D here, we have ax minus b over bx minus a. And then we're going to do the same thing where we divide the numerator and denominator by the highest power of x, which in this case is just x. So multiply both by 1 over x, and then we would have ax minus b over x over bx minus a over x. And that would give us a minus b over x over b minus a over x. And since a and b are both numbers, then whenever we divide them by essentially infinity, we're going to just have 0 because the denominator is growing and growing. So then in this case, we'd be left with a over b. So that means that our limit is a over b.
All right, now moving on to number 5. We have let f of g of x equal 3 times the square root of 2x minus 1, and g of f of x equal square root of 6x minus 2. Find possible formulas for f and g. So to go about this, the first thing we're going to want to do is we need to recognize that this is a function of g of x. So 3 times the square root of 2x minus 1. Now we have this function of g, function of f of x, g, which is a function of f of x, which is going to be the square root of 6x minus 2, which is the same as 2 times 3x minus 1. So if you look at this, you can see that g of x is the square root of 2x, and f of x is equal to 3x minus 1. Next, we're going to go ahead and look at the salt water flowing into a large tank, and the concentration of the salt in the tank is given by C is equal to F of T, which is equal to 1.2 T over 100 plus 60 pounds per gallon, where T is the time in minutes after the salt water started flowing into the tank. So what we need to do here is we need to solve for T in this equation. So the first thing we'll do is multiply our 100 times 60 over. Now we need all of our t's together, so we're going to go ahead and distribute this out. Now we're going to subtract our term with the t in it to the other side. Now we're going to factor out our t on that side to finally get our answer of t is equal to 100 c divided by 1.2 minus 6c. Now for part B, we are going to evaluate f negative 1 of 0.15 and explain its meaning. So we're going to go ahead and plug in 0.15 here. So t is equal to 100 times 0.15 over 1.2 minus 6 times 1.5. You can just go ahead and put this in your calculator and you'll get 50. So what we need to say about this is when the concentration is equal to 0.15, time is equal to 50 seconds. 50 minutes. 50 minutes. Suppose the function f is related to the function of g by f of x is equal to 4 times g of 3 times x minus 5 minus 2. If we have the point negative 9, 6 lying on the graph, what is the point that's going to be on the graph of f? So we need to see that in the horizontal, we are going to compress by 1/3. And we're also going to shift to the right 5. And that's from this 3 and this 5. Next, for our first vertical transformation, we are going to stretch by 4. Then our second one is we're going to shift down 2. So now our first horizontal transformation from -9 is when we compress by 1/3. So we're going to do H1, and that will get us -3. Then we're going to take that and we're going to do H2, and we are going to shift 5 to the right, which will get us a +2. Then for our vertical point, 6, we're going to start with V1, which puts us at 24 when we stretch it by 4, multiply by 4. Then V2 shifts it down, 22. So our point is going to be 2, 22. So now, same thing. If G has this range and domain, what are the domain and range of F? So if our domain is going from -12 to 12, we know that this is our horizontal values. So the first thing we're going to do is H1, which is going to compress it by 1/3, making this -4 and 4. Then we're going to do H2, which is going to add 5 to both of these. So our new domain is going to be 1, 9. This is our domain. Now, for our vertical, we have that our vertical is going to be the same, -12, 12. We have to start by doing V1, multiplying them both by 4, so that'll get us -48, 48. Then V2 has us subtract 2, so that's going to be -50, 46, and this is our range. A bathtub was partially filled with hot water when the cold water tap was open. 2 minutes later, the bathtub held a total of 48 gallons. 5 minutes after turning on the water, the bathtub held 61.5 gallons of water. So that gives us 2 points, 2,48 and 5,61.5. What was the rate of change on the interval 2 to 5? So here we're just going to do our simple slope formula, which is 61.5 minus 48 divided by 5 minus 2, which gets us 13.5 over 3, 4.5 gallons per minute. Next, how many gallons of water were in the tub at the time the cold water was turned on? So we're looking for T is equal to 0. It's our question mark. So we know that our gallons is going to be a linear function because it tells us linear functions. So that's mx plus b. We know b is when t is equal to 0, or x is equal to 0 in this case. And we know our m is 4.5. So we have g is equal to 4.5 t plus b. Now we're going to plug in a known point. We know that at 2 minutes, there's 48 gallons. This tells us that B is equal to 39. Therefore, it's 39 gallons at time t is equal to 0. Next, we have to write a formula for each of these situations. So we're going to start with A. Median home prices in the U.S. were about $186,000 at the end of 2008 and fell by about 2.5% per year for a few years. Let M be the median home price and T the number of years since 2008. So we know that we have this formula, P times, and for decay, it's going to be 1 minus the rate to the T. So in this case, it's going to be 186,000 times 1 minus the rate, which is 2.5%. So that gets us 0.975 to the T. So that's part A. Now, same thing for part B. annual salary, and this time it increases by 3.2% each year. So for this one, we're going to do P times 1 plus R to the T. So this one for B is going to be D is equal to 30,000 times 1 plus 0.032 to the T. And now for part C, we have a population of 1 million bacteria in a petri dish is growing at a continuous, so remember that means P E to the RT whenever you have anything continuous, at an hourly rate of 8.66%. So here we have 1 million. 1, 2, 3, I need one more zero, is equal to the bacteria times E to the 0.0866 T. And the last one is initially there was 100 milligrams of radioactive tritium, and it was decaying at a continuous yearly rate of 5.63%. So this is the same thing, it's continuous, but it's decaying. And since it's decaying, we have PE to the negative RT. So this here gets us 100 E to the negative 0.0563, which is just this number, T. So that's how you do all of those.